Hi everyone, great to see you all here. So thanks for the introduction, Nick. So today I want first to discuss Zenseact open dataset, and after that I will talk briefly about a few applications of federated field learning that uses ZOT and Flower as well. So let's get started with the big picture. So as you know, the high number of fatal accidents and severe injuries is a big problem in our society. And notably, most of these tragedies are due to human mistakes, like 94% of those tragedies. And this is something that technologies like autonomous driving can reduce these numbers significantly. But what is needed is a larger scale and comprehensive data from real-world driving, which is something that not everyone can afford or have access to, which means that basically it hinders the development of autonomous driving and consequently road safety in general. So at Zenseact, we decided to basically share part of our data for public use to encourage collaborations and joint efforts to improve the road safety and advancement in autonomous driving. We call this dataset Zenseact Open Dataset, or ZOT for short. But maybe you wonder, okay, what is this dataset about? So this is a larger scale multimodal dataset, which is collected over 2 years in different European countries. And it's basically much larger than other available AD datasets. And beside that, basically it has highest resolution and highest range sensors. And also we cover highest diversity. I will talk about it later on. We also provide detailed multitask annotations for several perception tasks. And most importantly, we released this dataset with a permissive license that allows both commercial use as well as research. And we come with a software development kit that facilitates the use of it. How we collected this dataset, we used our developmental cars with the same sensor suite, each with a high-resolution camera, with long-range dense LiDARs, and also high-precision GNSS and IMU sensor. We also provide, in addition to these sensors, we also provide some vehicle data that might be applicable for some applications, as well as satellite positioning. But like a little bit more details about the dataset, it's actually categorized into 3 subsets: frames, sequences, and drives, each targeting a different application. So what happened? Okay. Frames are basically single camera images that with 2 seconds of other supporting sensors. We also provide multitask keyframe annotations for those. Sequences cover 20 seconds of the full sensor data, and drives are similar but last for several minutes, like 1 to 6 minutes. And as seen here, and I mentioned briefly earlier, it has a high diversity. So we collected this data set in different road types, like highways, urban, rural, and such, under different weather conditions, foggy, snowy, cloudy, and so on, and under different times of the day, night, twilight, and so on. So it covers the highest diversity. We also provide, as I said, some multitask high-quality annotations, such as 2D, 3D bounding boxes for the static and dynamic objects, or instant segmentation for lanes, as well as traffic sign recognition. So please check out our website if you are interested to know more about this. And yeah, don't hesitate to contact us if you have any questions or want to have any contributions. We look forward to that. So by that, it was a very quick overview of ZOT, but I think that was enough to understand the rest of the talk. So now I want to switch gear a little bit and talk about a few applications that are basically how we can use federated fleet learning for that uses Zod as its data set and also Flower as its federated learning framework. But besides going dive into those projects, let's have a quick look at the high-level AD software stack. So it looks something like this, and basically the perception stack is a couple of like usual modules that run in a AD software stack. And most of these modules nowadays are deep learning based, which means that most of them are supervised and they need high quality annotations that are usually provided by skilled human annotators to be trained, right? One of these modules, as you saw before, is lane detection. And as I said, it's supervised and needs annotation. So assume we want to update this model in a federated fleet learning setting, which means using our customer data. Data cannot leave the car in that case, like our customer car, due to reasons that we are all familiar with, privacy and regulations and bandwidth limitation in our case as well. So the other challenge is that accessing skilled human annotators in the car is also challenging. So one potential enabler could be that we use other sensors in the car, such as high-definition maps that contain detailed information to kind of label the data and create 3D lane labels. So in a research project, we actually did that, and we used high-precision GNSS sensor. We localized the car. We used that information, query map around that position. And then we filtered out just kept the relevant information, lane information, and then we project that back into the road coordinate. And then we end up with 3D lane labels, something like, as you can see here. With having that, then basically we can train an end-to-end 3D lane detection model, something like this one, for instance. I will not go into details because of time, but we can discuss it later on. But then the inputs to this model will be the input images, and the outputs will be the 3D, the automatically generated 3D lane labels that we discussed. So then we did that, and we saw that basically by doing that, decentralized learning with fully automatic labeling can reach unpaired results with centralized training. And also we saw that it's not that far from actually decentralized learning that uses manual labels, not automatically generated labels, right? This is promising, that basically we can train such models despite being supervised in the car. But still we can make it more sustainable, because label generation in the car is non-trivial, and it requires a lot of resources, and while we have restricted resources in the car. So in another study, we looked into semi-supervised learning, and we actually trained model with extensive unlabeled data and very limited labeled data in the car. In that project, we focused on another components of AD perception stack called road segmentation, which basically says where the car can drive, where is drivable actually. And that one is also a supervised task. Okay. For that, we adopted an algorithm maybe some of you are familiar with, fixed match seg, which is suitable for semantic segmentation task, and it basically works with a minimal number of labels, and then it uses an extensive set of unlabeled images and do different augmentations, and then do regularization and pseudo labeling, and then use that information to improve the performance of the model. From that project, we saw that federated semi-supervised learning can reach comparable results actually with centralized semi-supervised learning. And its result is not too far, as you can see in the top, it's not too far from that, which is a centralized supervised learning, which benefits from much more labels, like 50 times more labels. So we expect that by using more unlabeled data, perhaps we can shrink this gap even further. Yeah, and that was it. There are more applications, but I thought maybe this two is enough for now. And I have a news that now we have actually integrated Zenseact Open Dataset with Flower and Hugging Face Dataset, which is great. Thanks a lot to Adam from Flower Dataset for the great help. And we hope with that we can facilitate federated fleet learning for vehicles, and at the end we can improve the road safety as a consequence. Yeah, thank you for listening.
That's amazing. Last time I talked to Adam, it hasn't been finished. That's how fast we move.
Actually do it during the talk.
They did it during the talk. Wow, that's incredible.
Yeah.
Any questions? Any questions?
It will be updated with more annotations also. But, yeah.
Great, great. Any questions? Oh yes, in the back there.
So in this setting, thanks for the
thank you.
nice presentation. In this setting, the client is the car, each car, is that correct?
Yes, that's true.
And how does it transmit the information?
Actually, we can, when the car is stable and connected to the charger, then you can use more cable Wi-Fi, which is more stable than 4G or 5G that is available in the car. But that's one of actually the challenges that, especially with, for instance, LiDAR data sets, which are really big. It's a big challenge that how to send the data out of the car, which is optimized, and at the center or wherever you can also, retrieve it in a good way that you don't lose information. But if we can actually do the training in the car, then we don't need to send the data out, right? Then that's one of the biggest benefits, because then we save bandwidth, we save energy in the car, and so on. But of course, it comes with some trade-offs, and we need to have the compute available in the car and things like that. But when the car is stable, then the compute is not being used, right? Then why not using it for updating the model? Yeah.
Great. Any other questions? Oh yes, this gentleman just here, just beat him.
Yeah, so I have questions. The number of the cars, how many cars actually involved in this federated learning? And the second question is, you cover multiple the countries, then maybe each car, maybe one car is located in Spain and the other car is located in Sweden, or how looks like a little bit detail in your experiment?
Yeah, actually in the projects that I show you, it's not really larger scale, to be honest. It's a limited number of cars, but they were from different geographies. For instance, in the 3D lane project that I showed you, it was 5 clients and from Norway, Sweden, and Germany. But we are working on another project that we want to basically make it much larger scale, really do it with the fleet scale that we can see. Then if you are interested about data partitioning and how we can use it like this data set, there are lots of metadata available, and also the information about the location and so on. And also the name of the cars and so on. So basically we can partition the data based on that. We will soon implement that as well with Flower, but not yet.
Yeah, thank you.
Great. Let's thank Mina again. Thank you so much.